Okay, so now let's begin by addressing these questions. So sorry for the break there. So um, first question I ask, we wanted to assert a distribution to model the chance a random person of interest votes for Democrat in Wisconsin. So once again, we have a binary random variable. So a lot of these answers are going to have a similar flavor to the answers in the 309 setting, but I think a key point is just understanding the subtle difference is sort of going to give you an idea for how this course is going to be different from 309. So here, because we have a binary random variable, we're going to, again, model things using a Bernoulli distribution. P is the probability a person votes Democrat in the population. So this is not in the sample, in the population. And xi here is this binary random variable indicating whether person I votes Democrat. The key thing here to keep in mind is that P is unknown, unlike in the 309 example. So you might be tempted to think that P is 0.55 because that's what is going on in the sample, but that's not the case because that's only a sample of 100. That's not the entire population of Wisconsin. Okay, so now let's look at part B. So part B says that based on our sample, we want to make a guess for the proportion of people who vote Democrat in the population. And then attach a standard error to that estimate. So some of you may know how to do this, but this is, in fact, if you don't, it's really not an issue at all because it's something that we're going to cover in 310. So I'm going to be actually a little bit vague because we're actually going to use the concepts in this course to cover that. So the point of now is just to flag some of those ideas and concepts. But if you don't get it all right now, that's not such a big problem. So what we have is, recall that 55% of the sample votes Democrat. So 55 out of 100 vote Democrat. So we don't know what's going on in the population, which is, on voting day, what percentage of people are going to vote Democrat. And so how do we guess or estimate P? And again, we haven't actually learned how to do this formally, but, a number of you, might just say, oh, well, 55% of people in the sample vote Democrat. The best possible guess we can have is, maybe that in the population, we might expect it to be 0.55. So I'd use this notation P hat, which is something that we'll be using throughout the course to say that this is not actually P because we don't know what P is. This is just an estimate or a guess for P based on the data. And this will actually be covered more formally in chapter 8, but this guess of 0.55 is actually a pretty reasonable guess given the data that we have. Like any other guess, of all the guesses we could make, this seems pretty reasonable. And we want to attach a standard error to this. So recall that, D is the sum of these xi's, which in this case is actually given to us. So in the statistics setting or in, the 310 setting, the sum of these xi's are given and P is unknown. Whereas in the probability or 309 setting, the P is given and then the sum of xi's is unknown, and that's what we try to calculate. So we need to find variance of P hat and then take a square root to calculate the standard error. So the variance of P hat here is just going to be variance of D over 100. And then, once again, we can do a similar calculation to what we did before. And then the variance of P hat is going to be P times 1 minus P over 100. But recall that once again, we don't know what P is, so we can't really say exactly what this variance is. And so once again, we can guess or plug in P hat for P. And this is, again, a pretty reasonable thing to do. And so we can potentially attach a standard error of that as 0.05. And for those of you who've taken 302, you may already have an idea of doing something like this. But we're going to learn how to do this a little bit more formally in this course. So finally, in part C, we kind of are getting to the question that we really care about, which is, are the Democrats or Republicans, going to win on election day? So find the chance in brackets, and I say chance because we can't actually calculate that because we don't know what the underlying P is. We want to find the chance that P is greater than 0.5 based on the sample. So, this is typically referred to as like attaching some confidence or some chance. And so once again, like we did before, we could use the central limit theorem to say that, the square root of 100, D over 100 minus its mean divided by its square root of its variance is normal 0, 1. But once again, we run into this issue that P is unknown. We can try to plug that in for P hat is 0.55. And then we get to kind of this normal, this kind of expression in terms of D. But But now we have that D is actually known. We know that D is 55. So what do we kind of do next? And so this is where we're going to kind of use like we haven't really learned how to answer this question, and this is actually going to be covered in chapter 9. So the real question of what we're trying to find is, who's going to win on election day. That's not something that we really know how to answer yet, but we will, within maybe 3 or 4 weeks, 5 weeks of the course when we get to chapter 9. So just to provide a quick recap of, what we, the setting in 309 versus 310 and trying to contrast that. So in 309, P is known, and we know, so we kind of completely know the distribution, and we want to say something about the data or the random variable drawn from that. And in 310, and this is the more realistic setting, we're in the voting setting, we don't really know the percentage of people that will vote Democrat on election day, and we want to try to find that. But we have some sample data typically, a lot of polls are based on that. So P is unknown, but we want to use data to infer P. So we're getting to this more interesting question of kind of inferring population parameters of interest from data. So hopefully that just gives you a flavor of how this course is contrasts with 309 a little bit, but you can also see that a lot of the concepts we use in 309 kind of come up in these questions too, which illustrates the importance of the material in 309. Okay, so that's it for our first lecture. Hope this was reasonable for you to follow. I welcome any feedback by email or other means. We'll start to get into the material more in the next lecture. Thanks very much.